This is question 28, have a go. Okay, part A is very straightforward. Find the vector PB, so from P to B. Now we've got to do this in terms of little a's and little b's, so to get from P to B we're going to go down here, then across here. Both of those roads comprise little b's and little a's. So basically to get from P to B we're going to go P to A and A to B. P to A and A to B. Now P to A is going down this B and this 2B the wrong way, so that's minus 3 lots of B, whereas A to B is just a simple A, so our answer is minus 3B plus A, or you could have written it the other way around, A minus 3B. Now for part B this is much more difficult. We've got to show that NMC is a straight line. So basically what you want to do here is work out the vector NM, work out the vector MC, and first of all prove that they're parallel. Now if they're parallel they have their multiples of the same vector. So you're basically going to want to work out NM, MC and show that they're multiples of the same vector, and then finally not only must they be parallel but they're on a straight line, so you've just got to say they go through a common point. Now the common point that NM and MC are going to go through is obviously M. So let's do one by one. So I'm kicking off with the vector MC. Now MC is M to B then B to C. Now because M is halfway along PB, we're told that here, MB is half of PB. So MC is half of PB plus BC. Now PB we know from part A, PB is minus 3B plus A, and BC is another A because we're told that B is the midpoint of AC. So basically from then onwards it's just normal algebra. So multiply this out using the claw, so that's minus 3 over 2b plus a half a. Gather your terms and you get that MC is 3 over 2 lots of the vector A minus B. I've factorised to make it a multiple of that vector. Now repeat for NM. Now NM is going from N to P, P to M, and PM being another half of PB. Now N to P is obviously a little b. Half of PB, again we know PB from earlier, is minus 3B plus A. Do the claw, gather your terms, factorise, and we get N to M being half of A minus B. Now we've shown what we wanted to, that they're both multiples of the same vector, the vector A minus B, and then we just say they go through the common point M, and that proves they're on a straight line.